Alright guys, I am going to try work through some of these problems with you. I know that this has been a little bit of a challenge, but that's completely okay. So, I'm going to walk through the steps for naming these ionic compounds. Notice the top says name the following ionic compounds, keeping in mind that a transition metal cation must include its charge. So, the first one we're going to look, Ti, and we know that that means titanium. We're going to find titanium on your periodic table. Number 22, if you can see here, I'm pointing to it. Number 22 on your periodic table falls within the transition elements. Remember, the transition elements are anything from group 3B, so group 3, all the way over to group 12. Those are transition elements. Anybody in this region will require a charge listed because any of these elements has the chance to have more than one charge. So for titanium, you're just going to write titanium. We're going to do parentheses with the charge. And then oxygen, you just say oxide. Okay, remember, whether you have ionic or covalent, they both end in ID. Take off the ending and add an IDE. Now to figure out the charge here, what you're going to do is write titanium, Ti, and then oxygen, but you have two of them. So I'm going to change the color here to write the charges. Remember, down here, this subscript tells us how many oxygen atoms we have. So right now, we have 2 oxygen atoms and 1 titanium atom. What I'm going to write up here, these exponent or superscripts are going to be the charges. So you'll look at your periodic table and find oxygen. Because in order to find the charge for titanium, you have to look at the other element. So looking at the periodic table, oxygen is in group 6A, so that tells us it has 6 valence electrons. If it has 6 valence electrons, then its goal to be happy is to gain 2 more to have a total of 8 valence electrons. So titanium then has a charge of -2 because it gained 2 negatively charged electrons. Oxygen, -2. Remember, the nonmetal will always have a negative charge, and the metal will always have a positive charge. If oxygen has a -2 charge, I'm going to change colors again, because if I have, say we have 2 oxygen atoms, so one oxygen has a -2 charge, and you add another oxygen with a -2 charge, you have 2 oxygens, so 2 oxygens, each of them with a -2 charge. So if you add these 2 charges together, you would get -4. So the overall charge on those 2 oxygens is -4. So if your overall charge is -4, you know that because this is a compound, it is neutral. The charge is neutral. So now you want to say the titanium must have a charge that when added with this -4 equals 0. So what plus -4 gets you 0? 4 plus -4, so 4 minus 4 is equal to 0. Therefore, the charge on titanium must be a positive 4. So we write 4 in that parentheses. All right, so go back. We'll just type 4. So you need to do it in Roman numerals, so capital I, capital V. Titanium oxide. The answer. Now the next one is barium chloride. So again, the first step is you look at that first metal, and you look at your periodic table for it. Is it a metal, a transition metal, or not? So does it fall within group 3 through group 12? All right, so barium on your periodic table, it's going to be right here. It's in group 2. Therefore, we know that it has 2 valence electrons. So we do not need to do a parenthesis in the name. So if it has 2 valence electrons, we're going to say that it is going to lose that 2 because it's easier for barium to lose 2 electrons than gain 6. when it loses 2 negatively charged electrons, the charge becomes a positive 2. Positive 2 charge. Now chlorine, if we look on our periodic table, is in group 17. There are 7 valence electrons. Remember, the goal of everybody but hydrogen is to have 2. So it wants, or is to have 8. So it wants to gain 1 more valence electron to have a full valence shell of 8. If it gains that 1 more valence electron, then its charge is now a negative 1 because it gained 1 more negatively charged electron. Negative 1. Now, if we look here, this is already balanced, okay, because chlorine has 2 negatively charged, and you go 2 plus negative 2 equals 0. You will know that every time you see that that first element is not a transition metal, you can just simply write it as it is. The first element, you just say barium. And the second one, you just say as it is, you add IDETN. So barium chloride. That is it. Again, anytime that first element is not a transition metal, ionic bonding, ionic compounds are very easy to name. Right? Now we look at number 3 here. Notice that copper on your periodic table is found in the transition metal region right here. Okay, number 29, copper. Therefore, you will need parentheses. So at copper, put your parentheses in, add a liquor here. And then chloride. Because remember, when naming an ionic compound, the second element is just the first bit of the element's name, and then take off the end and put IDE. All right, now we're going to have to figure out what this charge is on copper. And the way we do that is by figuring out what charge this entire set has. So the first step is to figure out what the charge of one chlorine atom is. So we find chlorine on the periodic table. Here it is in group 7A. So because it has 7 valence electrons, it's 7A. So we know it's going to gain 1 valence electron. And when it gains that 1 negatively charged electron, it becomes a negative 1 charged particle. Okay, so it's negative 1, but write this again. You go copper Cl2. So I just said that this chlorine has a negative 1 charge, but there are 2 of them. So if there are 2 of these negatively charged particles, it is just like saying there's 1 with a negative charge plus another 1 with a negative charge. So it is a total of a negative 2 charge. The total is negative 2. Now the way you figure out what the charge on copper is you know that this is a neutral compound. Therefore, if copper is negative 2, if chlorine is negative 2, what must copper be if the sum of them is 0? So the number would be 2. If you have positive 2 and you subtract 2, then you have 0. So the charge on copper is 2. Then you type Roman numeral 2 in parentheses. Right, now we get to potassium iodide. Now if we look for potassium on the periodic table, so the K here on the periodic table, you will notice that potassium is in group 1. Therefore, it is not a transition metal because the transition metals are here. So because it's not a transition metal, we can just write it as it is. Say potassium and iodide. Remember, you change the ending to IDE, and that is all you do if it is not a transition metal. Now here we know SR is for strontium. And so is strontium a transition metal? Nope, it is not. So we can just type chloride. That is it. Strontium is not a transition metal. We can just write it as it is.